The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so for number 3, we're supposed to evaluate the integral of secant cubed of x over tangent squared of x dx. So the first thing you should think every time you approach one of these problems with trig functions is if it applies, or if one of your standard methods applies that you know for trig functions. For example, when you see secant and tangent, we have a couple of rules for dealing with integrals of big powers of secant and tangent. The rules, though, are if we have an even power of secant, we can do a particular thing, or if we have an odd power of tangent, we can do something in particular. In this case, we have an odd power of secant and an even power of tangent. Neither of those rules apply, so we have to think outside the box. We need to do something else here. The next thing you should think is that secant and tangent are involved together in a Pythagorean identity. If you remember, we have the identity tan squared x plus 1 is equal to secant squared x. So we're going to need to use this to kind of play around with this function to figure out something that works. So a lot of this is going to be trial and error, but I'll show you the steps here that work. What we want to do is we want to change two of these secants out of this secant cubed into this identity. So the first thing we're going to rewrite is we're going to have, instead of secant cubed, we're going to have secant x times tan squared x plus 1. So you should think to yourself that that's a logical step to make because we already do have a tangent squared. So this fraction is going to be able to simplify because we have a tangent squared in both the top and the bottom. So if we kind of split this up into the integral of secant x times this fraction here can actually be simplified to 1 plus cotangent squared x. Because tangent squared over tangent squared is 1. 1 over tangent squared, the reciprocal is cotangent squared. And finally, if we distribute this a little bit here, we'll get secant x plus secant x cotangent squared x. Well, the integral of secant x is something that you guys know. If not, that's something you should have memorized for the test, certainly. Secant x cotangent x, though, or secant x, sorry, cotangent squared x, we need to see if that can be simplified at all. And maybe the easiest way to do that is kind of convert it to sines and cosines and go from there. Secant x is 1 over cosine x. Cotangent squared x is cosine squared over sine squared. So you can see here that we get one of these cosines to cancel out. We're left with cosine over sine squared, which could be written as 1 over sine x cosine x over sine x. And the reason I'm writing it that way is because this is one of our standard trig derivatives. This is cosecant x cotangent x. So secant cotangent squared is the same thing as cosecant x cotangent x. Cosecant x cotangent x is a common derivative. If you remember, that's the negative cosecant x cotangent x is the derivative of cosecant. So finally, our problem becomes integral of secant x plus the integral of cosecant x cotangent x. So now this is something we can definitely evaluate. The integral of secant x is ln of secant x plus tangent x. Again, that's one you should certainly have memorized. The integral of cosecant x cotangent x is going to be negative. Remember, because the derivative of cosecant is negative cosecant cotangent. So if we're integrating cosecant cotangent without the negative sign, that means we have to put it back in the original. So we're going to get minus cosecant x plus c as our final answer, because that was an indefinite integral. So some of you might be wondering, like, how would I know to do those specific steps? It's something you really have to play with for a little bit and try a bunch of different things. But if it doesn't conform to one of your basic trig, higher power of trig function rules, like you have rules for powers of sine and cosine, you have rules for powers of cosecant, or of secant and tangent, a similar rule for powers of cosecant and cotangent. If it doesn't conform to one of those, you're going to have to try to use your trig identities to break it down into something more familiar. So obviously there's a lot of other paths that you could have taken that probably would not have come out as simply as this, or maybe just become impossible. So you're going to have to work with it to try to come up with some common trig derivatives when you're messing with the function you need to integrate.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.